In this lesson, we're going to be talking about firewalls and their uses. Now, what is a firewall? Well, a firewall is actually kind of a vague term because there's so many different types of firewalls, but primarily a firewall is a network device that has the ability to block or otherwise manipulate traffic coming into the device, either in a way that it can be logged or maybe forwarded to another network after undergoing some manipulation. So like doing network address translation, for example. So there are a lot of different firewalls that are available. As a matter of fact, if you've got a device like a DSL modem or a cable modem, there's probably some sort of firewall built into that. Now, there's a lot of commercial firewalls as well. For example, Checkpoint and Juniper both make really good firewalls of a commercial variety. There's also firewalls that are built into the various operating systems. And what I'm going to show you here is actually the Linux firewall, which is called IP tables. And I'm going to show you some of the capabilities of firewalls just as an example of what they can do and how you might be able to use them. So with Linux, there's this command called IP tables, which is, of course, why the firewall is IP tables. It's named after the program. And I've got here IP tables, and what I'm doing is a list of all of the rules and policies that are currently in place within IP tables. And these are stored inside the kernel space. And so these are all of the rules right now, and you can see there's a lot of accept. So that's on the input chain, and on the output chain, there's a policy of accept. So with IP tables, without getting into a lot of the minutia of how it works and how everything comes together, there are these things called chains that allow you to add rules to the individual chains. And the chain is associated with a particular behavior. So for example, there's the input chain. So that's anything coming into the device. There's a forward chain. So if you've got two network interfaces, a forward chain would allow you to forward packets from one interface to another interface. And of course, the output chain is anything going out of the device. So one of the things that we can do with firewalls, in addition to just blocking, which is really helpful when you're talking about a network attack, from a forensic standpoint, there's some benefit to doing logging. And let me show you something here on how I would do logging with IP tables. So I can log traffic coming into this particular device. So what I'm going to do here is I'm going to tell IP tables I'm going to append a rule to the input chain, and that's the -a is append, and I've specified the input chain there. I'm going to say the protocol is ICMP, and I want to do ICMP-type equals 8, and that is specifying that I'm going to do something on an echo request. So with ICMP, there's a lot of different types, and those are flagged in the ICMP header. In this case, we're looking for an ICMP type of 8, which is an echo request. And what I want to do with that is I want to log it. So now I've got a rule that I'm going to log all ICMP echo requests. And I ought to be able to take a look now and do my list. And you can see down at the bottom of the input chain, there is a log target, and it says ICMP. So we're logging ICMP echo requests. So now let me go over to another window here, and I'm actually going to initiate some ICMP echo requests to that particular system. So you can see the ICMP echo request is getting through, and the computer is responding to it. Now I've done the ICMP echo request or the pings, and I'm going to go back over here, and I'm going to go into the log directory on the system, And it depends on how you've got your syslog or your logging daemon set up as to where it's going to land or where those messages are going to land. But I'm going to say that they're in the kernel log. Now we've got a lot of log messages here, and it's not clear immediately from looking at it, unless you know what you're looking for, that these are the log messages that I had the kernel create, because it doesn't say IP tables. It doesn't say immediately, hey, I found an ICMP message. It's just a line that specifies that there was some network traffic that was captured. Now I actually have to read the line to indicate what it was that was captured. So we can see a source address of 192.168.1.23 and a destination of 192.168.1.39. And you can see we've got the input is BR0, which is the network interface that it came into. And we've got another line here that says phys_in, which is the physical interface, which is ETH0. So there happens to be a bridge interface on this system where it looks like the traffic came into, but the physical interface that it arrived on was ETH0. And you can see further down on this line, proto equals ICMP. So the protocol was ICMP and the type was 8. So these are the log messages that we've got for this ICMP rule that I set up. And we can go back to the rule again and see that we've got this ICMP rule for logging this particular traffic. And that's what a log message looks like. So again, it's not really immediately readable in terms of being able to figure out quickly what's going on. You've got to be able to understand what the line is saying to you, which helps if you understand networking and protocols and addresses. It's not entirely cryptic. It does have some keying markers in there. So you can see SRC as source, DST as destination. You've got the proto in there, and you've got the ICMP type. In this case, it happens to be ICMP, so we're going to flag what the type is, and it's got the interface information as well. So we've got all of the information about the packet. And again, there's all sorts of different types of things you can do with this. You could set up a drop rule, for example, and also log it. But in the case of forensics, what you really are probably interested in is what's going on. And certainly you could do that with a packet capture and set up some filters. But if you don't always know what it is you're looking for, or maybe when it's going to come in, something like this would work out pretty well. So you could set up this firewall rule and then set up a log watcher on this log so that an alert goes off when these messages start to show up, at which point you could fire up a packet capture and start capturing the traffic so that you've got it. It saves some time and resources, and certainly disk space if you're doing something along those lines. And using this for, like the intrusion detection that we've talked about in a different lesson, we've got this ability to log traffic and potentially alert on it using firewalls. And of course, we've got the traditional use of firewalls as well, which is doing blocking. And you can see here under the forward chain, there's a couple of reject rules, and that's what IP tables does with traffic that you don't want. And there's a bunch of different ways you can do rejects. You can just do a straight drop, or you could reject with an ICMP port unreachable, which is what you see here. So there will be an ICMP message that goes back to the sender saying that port was unreachable. So that's firewalls and some of their usage. And again, there's a lot of different types of firewalls. I've just shown you one because it's readily available and easy to use. But again, there's a lot of different commercial firewalls as well. And there's certainly ones that you will probably see on a regular basis if you've got home networking where your interface to the internet has some sort of firewall built into it.